Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hello, everybody. So, I hope you all are fine. And today, in this video, we're going to look at an example of question and answer for chapter 3.3 beam design, where we have this question. So, we're just gonna straight away look into this question. Alright, so figure 1 and figure 2 below, this one and this one, figure 1 and figure 2, show a simply supported beam with 5 kN per meter live load. So this simply supported beam here, in figure 1, it shows here we have live load as well. So now we have, in our consideration letter, we got to check this self weight as the dead load, and then we have to add with, we have to also consider live load, 5 kN per meter. And the force diagram, so this force diagram for the simply supported beam respectively. Alright, so this is simply supported beam, this is a force diagram. So here we have a lot of information going on here. Alright, so we really have to understand this. So this is B, the width shows here is equal to 0.3 H, and this here 309 minus, this is actually the Z. If you remember from our force diagram, this is the Z, where the Z is equal to D minus 0.45x. So here 309 is our D, our effective depth. Right, so we're going to check later on why do we need this information. The beam is to be cast of grade 30 concrete. Okay, so this is the FCU 30, and reinforced only in the tension with high tensile reinforcement bars of 460 megapascal. So this is the steel strength. Reinforced concrete unit weight is 2,400 kg per meter cube. So this is unit weight. Normally we got 24 kilonewton per meter cube, but in this question it is given to us in kilogram per meter cube. So we need to change this unit to kilonewton later on. Kilonewton per meter cube. Assuming gravitational acceleration g is equal to 10 milli per second square. The beam is to be designed with nominal cover of 25 mm. Nominal cover, so the C is 25 mm, the R 10 links. Alright, so this 10 mm links, diameter links, 12 rebar, so 12 mm diameter for the rebar. Based on the figures and information given, calculate the total design load of beam, the maximum bending moment that neutral exists, the area of steel required, the number of steel rebar needed, sketch the cross-section details, and check whether simply supported beam can withstand ultimate bending moment of 50 kN/meter. Right, so we're gonna do all this in this question. So we're just gonna do this quickly. Alright, class. So here we can see the question. So I'm just gonna put it down here, and this is the figure. Alright, so the first question is to find the total design load of the beam kN per meter. Alright, in order to do that, before that class, we need to list out all informations given to us so that we clear what we have and what we don't have. Alright, so first of all, it's mentioned here the grade of the concrete is 30, so we're just gonna write down here. So our FCU will be 30 Newton per millimeter square, and then our Fy, the steel strength, is 460 megapascal, which is megapascal is actually the same as Newton per millimeter square, the same as megapascal, sama saja. Alright, reinforced concrete unit weight, so the unit weight of concrete. So just gonna make you know, I just want to make sure that you don't get confused. It's actually spelled like this, gamma. So this is unit weight of concrete. It's gonna be 2,400 kg per meter cube. So if we change it in kilonewton per meter cube, it would be 24,000 times with 10, which is the G. Okay, the G is 10. It's given from the question here, right? It would be 24,000 Newton per meter cube. But we want to change each in kilonewton, so divide by 1000 ataupun times 10 to the power of -3. We get 24 kilonewton per meter cube. So as usual, as the same as typical number that we have previously in any other questions. Alright, so next, the beam is to be cast, to be designed with nominal cover. So C is 25 mm, and our rebar, the links, sorry, the shear links, okay, link diameter, diameter of link is 10 mm, and the diameter of rebar would be, is given here, T12 means which is T12 means that it has high tensile steel material, with 12 mm size. Okay. Do we have anything else? No. Alright, now the next thing that we're gonna get from is from our the next information we're gonna get from our diagram here. So we don't mind about this, but this one, it says here that D is 309 mm. Right, this is the D. How do I get this one? It comes from this. So if you look at your force diagram, this is actually D minus 0.5 x. Alright, so you just have to know that D is 309. Okay, alright, and then it says here the B is equal to 0.3 h, meaning that if we have our cross section of the beam, right, so this is 0.3 h, and here is our h. So we need to know this area here. We need to know all this so that we can calculate the self-weight of the concrete. So you have to know that you need to find the B and the H. Alright, let's do this. So let's find H first, class. So what is H? So normally, the normal question that you have usually, the question gives you H first, and then you have to find D. Right, that is typical one. Okay, D is given, then you have to find D. But in this question, it's vice versa. Okay, it's different. Now the D is given. Now you want to find the H, class. So this is this is so important to check whether you really understand what is exactly D and what is H. So H is the total depth, and D is the effective depth. So right, so here the D is given. So the D is where, which is from, if we have our rebar here, so it's actually at the middle of the rebar. Then we're gonna have links here. So we're gonna have links, and then we have this nominal cover. Alright, so in order to find the the H, so we're just gonna check. So H, this one, H is actually the D here. Just gonna change the color of the pen so that you know that I'm answering. Now we're answering the question. So H is equal to D, this D, and then plus with the shear links, plus with the half of this part. Right, so just gonna make sure you understand. So the D here is actually this one. Now we have half of the diameter, and then we have the links at the bottom. So D plus with the rebar divided by 2. So half of this rebar plus with the shear links. Alright, the links, and plus with the concrete cover. Alright, so just gonna bring here. So we know that from the information given, therefore H is equal to D is equal to 309. The rebar is 12, so 12 by 2 given here. The link is 10 mm, 10, and plus C is 25, if I'm not mistaken. 25 mm is given from the question. So 25. So we're gonna get for here. Okay. Sorry, pardon me. Alright. So the H we're gonna get is 350 mm. That is our H. Now we can straight away calculate our B, where B is equal to 0.3 H, which is 0.3 times with 350, which is 105 mm. So now this information that we get. So now we can redraw this cross section. Therefore, we know that our cross section this H here is 350 and the width is 105 mm. Okay, now we can answer the next question for the total design load. So from the diagram that we have here, just gonna bring it here. Let's bring this diagram here. So now we have to find the self weight of the concrete first. So the self weight is equal to, right? So the self weight of beam, so here, this part here. So you want to know the weight, the self weight in kilonewton per meter. Therefore, we have to Y conc times with the B times with the H. So Y concrete is 24 kilonewton per meter cube times with the B. The B is 0.105. Okay, remember this is kilonewton per meter cube. So you want to have the unit in meter times with the, this is 350, 0.35 meter here. So we're gonna get our answer, which is equal to 0.882 kilonewton per meter. So in this case, the self weight is actually the GK. Alright, never mind. So now we have our self weight. Now we want to know the design. So the design load would be the formula. So make sure you put down the formula in the question. If the question asks you to find the design load, show the formula first. So 1.4 GK plus 1.6 QK. So in this case, 1.4, the GK is the self weight only. We don't have anything else. So it's going to be 0.882 plus with 1.6, and the QK is actually the live load here, times with 5. And we will get the answer 9.23. I'm just gonna stick with, alright, for the sake of accuracy, I'm just gonna put 4 decimal places, but for you, you can just choose 2 decimal place or 3 decimal place. Right, for this question only, I'm just gonna use 4 decimal place only for this question. I repeat, so 9.2348 kilonewton per meter. Okay, so again, self weight, we have the live load is given, calculate design load, and now we have our first answer. Now we have our question 1. Right. So the next question is, now we have this whole question. It wants the answer in kilonewton per meter. The maximum bending moment M in Newton millimeter. Alright, so we're gonna use this formula. So because this is now actually class, now once we have find the design load, actually what we can say is, now we don't have this anymore. We don't have this, we don't have the self weight anymore. What we have is the total design load. So meaning that we only have one beam here, a beam supported. Alright. And then we have one design load, which is 9.32348 kilonewton per meter. Okay, this is the W. Now we can see this where we have one beam with one UDL only. Alright, now we can see like this. So here, for our M question, so our second question, this is question number 1. So question number 2, right, pardon me. Question number 1 actually start from here. Right. Okay. So question number 2, just gonna straight away use this formula. So when we have a simply supported beam with one UDL throughout along the beam, maknanya it fills all the beam here. Okay, therefore the M is, we can take as WL square divided by 8. Okay, so just gonna put down W which is this one, 9.2348. The length, since this is kilonewton per meter, so the length is 5000 mm. Therefore, we're just going to change it to 5 meter. Alright. Okay, notice that in the figure, it doesn't show us the unit. But in design, it's typical. Your dimension will be given in mm. It's automatic. Okay. Right. So otherwise, the question will mention this is in meter and millimeter and whatsoever. Right. Square, don't forget the square, divide by 8. And if you check in your calculator, the answer would be 28.86 kilonewton meter. But the question asks us not in kilonewton meter. Do not forget about this. You really have to attend all the questions. Attend the question. So even though you know the answer is correct already, but the question wants us in Newton millimeter, so you have to change this from here already. Right? So the same goes to 28.86 times 10 to the power of 6 Newton millimeter, and that's it. Now we have answered the second question. Okay, and I believe the third question is to find the neutral depth, neutral axis depth. Alright, so we want to find the x here. Okay, class, so for this question here, alright, we might need this one. Now we want to find our x. So this question we're just going to use. So third question, x. Okay, so I'm going to start with the concept of total m, assuming positive, is equal to 0, and I will start at point FST here. So I don't know how you mentioned here. Maybe like this one. So we about this point, we can choose either this point in any point here. So all this will be equal to 0. What this exactly means, which is the moment resistance, the MR, which is the resistance, the moment resistance from the material that we have here right now. Okay, so the resistance, which is the strength. I wouldn't say it's the strength, but it's kind of the strength. So if I ask you how many punch that you can take, oh, my resistance is 20 punch, means that you can resist 20 punch, but after that you will fail. So the same goes here. This is the material. The calculation for the MR is the resistance, the moment bending moment resistance for this beam that we are designing. So what it wants to resist. So MR is this one. So it's gonna rotate this way. So MR want to resist this part here. Remember that you calculate M. So M is the given load. So M is the punch. It's given. The given punch. So again, remember, you can, how many punch you can resist? What you want to resist? You want to resist the punch. So the M should be in other way. The other way, in the other direction. So you're gonna get, if we're using this formula here, so MR is in clockwise. So M is anti-clockwise, and this equal to 0. Right. So we can say that MR, what is our MR? So just gonna put our finger here and check for the so we have, so FD, just FD, and the D is, so just gonna put MR is equal to FCC times with, right, the Z here. So just gonna put Z, and minus with the M is 28.86 times 10 to the power of 6. So what we want to know, what you really want to understand here, we want to solve this question in Newton and mm. So that's why we want to change this. Okay, where from the formula that we know that okay, so what is FCC? You still remember you had it, right? So this, I'm not sure if the formula is given to you or not, but most likely it will be given to you. But assuming it doesn't, so you need to check your stress diagram and your force diagram. So you know that FCC is actually 0.45 FCU times with the area of concrete under compression, where 0 is equal to 0.5 FCU. ACC is actually 0.9x times with the B. Right. Okay. So I wouldn't go to the extent to explain how do we get all this. You can check my older videos talking about the beam design. Okay. So here we're gonna get FCC 0.5 FCU, which is 30, and the B is 105, and then times with 0.9x, we're gonna get this one as 1275.75x, right? So FCC, so goes back here. So FCC Z is 309 given to you, 0.5x, right? And minus 28.86 times 10 to the power of 6, and this is equal to 0. So the FCC here, just gonna replace it to 127.75 times with 309 minus 0.5x, .86 times 10 to the power of 6 is equal to 0. And then we times everything here, we're gonna get, okay, alright, we're gonna get 394206.75 x. So this part, then for this part, minus with 574.09 x square. We have, alright, I forgot to put here x. Right, don't forget here. So just gonna put down this bit here. Is this bit. Right, and minus with 28.86 10 to the power of 6. So I just want to rearrange so that the x square will go the other way, and the x is at the middle, and I want this x square will be in positive. So we're gonna get 574.09 x square. Right, this is positive, but we have to change it. So this is gonna be negative minus 394,206.75 x plus, this is going to be changed to positive 28.x6 times 10 to the power of 6, and this is equal to 0. Now we have our quadratic equation. So we just want to solve this by using this formula here. Right, so it's gonna use different pen here. Alright, let's use green then. Now we're gonna get x is equal to negative b plus minus square root b square minus 4ac divide by 2a. Okay, right. So if you make the replacement here from this value here, and we're gonna get x1 equal to, actually you can just use calculator, but you have to show this formula here. Okay, we have marks for this formula. Alright, if you want to be much better, you can even give this formula and then show all the replacement. Okay, all the replacement for B, for AC, and so on. So we're gonna get x1 is equal to 83.32 mm, and x2 is equal to 603.34 mm. Notice that I use this unit mm because x is actually the natural axis depth in mm. Alright, so which one we're gonna use? We're gonna go with this one. Why? Because our D is 309 mm. Therefore, our x shouldn't be bigger. Shouldn't be bigger than D. So this is the most rightful answer. So this is our x. Therefore, just mention x is 83.32 mm. Alright? Please do mention this. Do mention it. Do not just leave the question like this, the answer like this. If the question like this, so the examiner can assume that, okay, you don't know which one. Which one is x1, which one is x2. Please, at the final part, please show that, therefore, x is equal to 83.32 mm. Because this one is x1, this is x2. But the x is actually the x1. Okay. Alright, so now we got our x. So what do we have? What next do we have? Alright, the next question, find the area. Alright, area of steel. So as typical as can get. So we can straight away use this formula. So we know that from our diagram here, just gonna use this again. So we know that from this diagram here, the FST and the FCC should be equal to each other, right? So this is equilibrium. Otherwise, our beam will be moving. So we don't want that. So question number 4, find AST, area of steel under tension. So here we can use this Fx equal to 0. Therefore, FST, alright, will be equal to FCC. Alright, so FST, what is FST? FST is 0.95 Fy, area of steel under tension, should be equal to FCC. Okay, if you still remember last time we get FCC is equal to if you want we can just put it back. So FCC is 0.45 FCU and then ACC. But this actually we have already calculated it in the question here. So it's going to be 1275.75. 1275.75 x, where x is equal to 83.32, right? And we're gonna find out that, okay, you can use your calculator. Therefore, we're gonna get AST, which is equal to, so we're gonna bring this to the other side. So we're gonna get AST equal to 243.239 mm square. Don't forget the unit, which is in mm square, right? AST. Now we have answered the question. Okay, I really suggest you show all the details. But this one I want to make this video a little bit shorter. I'm not gonna show it detail. But for your answer in SPM 2, it is much recommendable for you to show your the detail of your calculations. Now we have AST, and the next question asks us to check the number of steel rebar needed. So question number 5. Right, so question number 5 here, it says that number of steel needed. right? So we know that AST should be equal to pi d squared over 4 times fifth number of steel. So we have AST 243.239. Our D is 12 square. From the 12 here, from the question, T12. T12. So T is the diameter, which I just use this one. Same thing. And T is the high tensile steel, the material. Okay, and this is equal to number of steel times 10 number of steel. So we just bring it over here. Therefore, we're gonna get N is equal to 2.15. Right, no unit because this is number of steel. Therefore, we're gonna use how many? We're gonna use 3 number of steel. Right, and then your final answer should be 3. Use 3T12. T is given 3, just the number here. Okay, use 3TF. Okay, hence use 3T12, meaning that we have 3 rebars. Okay, why do I, if you, alright, this is not just a simple run off, because if you run off, you're gonna get 2, but not 3. But in engineering, imagine that you need at least 2.15 number of steel, and then you use 2. So then that's gonna make your structure fail because you don't have enough, enough number of steel. So instead of less, we're just gonna choose run off and the bigger one, which is 3. Right, that's the idea. So now we got our answer for question E. Right, and then F, sketch the cross section, and it asks you to show also links and hanger bars. So how do we do this? So question number 6. Question number 6, just gonna use this pen here. The sketch cross section. So just gonna put this here for our, alright. Oh, nice. 1, 2, and 3. Do not forget that we have 3. Remember, 3 diameter. And then just gonna put the hanging bars. Only two is needed. There are only 2 that we need. And then the links. I pardon my drawing. And the links. Right, make sure your box shouldn't be like this. It should be more like this one. Right? Okay, like more rectangular shape. Okay, because this is autocorrect, it goes like this way. Anyhow, and then we have all this, and then the label. So label here 350, 105. Sorry. 3T12, R10, the links, hanger bars, right? And that's it. If you want to give more detail, you can just mention here the C is 25 mm, right? Doesn't matter, right? But the one that implemented the information that are important is this bit here, B and H, and then the internal things here, the steel, the hanger bars, the R10, the shelling, and so on. And this is your answer for question number 6. And lastly, this question, I'm not sure if this question will go for our syllabus, but just in case, so I want to you familiarize with this information here. So check whether the simply supported beam is equal to is can withstand, right? So just gonna bring it here, change the color. Right, so let's check the last question. Finally, the last question, 7. G. Alright, just G. Check whether the cylinder can withstand ultimate any moment. So this mu is equal to 0.156 BD square FCU. Right, this MU is actually what? MU, the MR is, if I punch you 20 times, okay, if I punch you 20 times, so your resistance should be 20. If I punch you uh, 70 times, then your resistance should be 70 times, so that we can get equilibrium. Alright, so I'm sorry with my examples, but I think that one is much easier lah. So punching, I'm using punching. Okay, so but what is MU? So MU is the actual numbers of how many that you can really withstand. So let's say your M is 10 punch. Let's say you can sorry, your M is 60 punch. You are given 60 punch. Awak ditumbuk 60 kali. But therefore you must at least have your resistance 60 in order for it to be equilibrium. So what's given that you can resist 60 punch as well. But the MU is actually the real resistance that you really have. So let's say your resistance is actually 100. Therefore, if your M is given 60, then you can still withstand it. This is your real, the actual number. But this one that you really have to resist. So in the case, if right now not 100, I give you 50 only. You have 60 punch that you have. It's given to you. You are given 60 punch. Of course, you have to resist 60 punch. Of course, but your capability is only 50 punch. Therefore, you cannot withstand it. You cannot withstand 60. You can only go with 50. So if the question asks you, can you withstand 60 punch? No, you cannot withstand 60 punch. So the same goes to here. So this is our MU here. So we're just gonna check. The question asks us, can it withstand ultimate bending moment 50 kilonewton? So now if the question is, we have M kilonewton meter, therefore of course we need MR 50 kilonewton meter. Of course, so we know this. But can the actual strength cover? Okay, so we're gonna use this formula. It's given to you, don't worry. So B is 105, D is 309 square, and FCU is 30. Okay, then you're gonna get 46.92 kilonewton meter. Of course, this is in you're gonna get this one, and then I change it to kilonewton meter. Right, so this is your actual resistance, but you want to resist is 50. Therefore, you cannot. Okay, can. So just gonna mention here, the beam cannot withstand right. Just gonna show the answer. So this is your answer. The beam cannot withstand it. Okay, because because MU is less than the M, and then show here where 46.92 kilonewton meter is less than 50 kilonewton meter. So this one cannot withstand 50 kilonewton meter. Alright, but for this question actually, right, just to add some information to you. So for this question actually, we have find out that our M is actually 28.86 kilonewton meter. But so rightfully for our beam here, from the calculation, it can withstand. But this question specifically mentioned 50 kilonewton. So if the question asks you, can our beam withstand, can our beam is withstand 28, the M that we have calculated? Alright, yes, because it's bigger or equal than the M, which is 46.92 kilonewton meter is bigger than 28.82 kilonewton meter. Right, so this one just some extra note. extra. Okay, I hope now we have answered all these questions. I hope you understand all the things that we have explained. So Vim design, there are a lot of things going on, but I'm pretty sure that students, you will be able to understand everything, because the calculation quite will not go to certain will not be so complicated. You just have to know the data, the information is given, and then you should already know, you should know the formula that is given. Sorry, how to use the formula. Okay, so my advice, please class, please, okay, try to memorize. Okay, memorize what? Okay, stress diagram and force diagram. In fact, question can ask you to draw this with labels. So it's so important for you to memorize this. All the formula, all this I get from the stress diagram and from the force diagram. Okay, that's it. Thank you very much for staying tuned. Um, please continue with your revision. If you have any question, leave in the comment section. If you want to give any feedback, if is this video helpful to you or not, also leave the comment section. I really appreciate it. If you want to say thanks, to give appreciation, it really means a lot to me, so that I know that my video really helping students. And please also, if you're not yet subscribing with my channel, please do subscribe, and please like this video. Thank you very much, and assalamualaikum and goodbye. See you.